Man, it's hot out here. But I know what'll help. Some of this. No, not like that. I'm talking about what doesn't get inside the bottle. The waste. And how it can be used to solve a problem like this. Hi, I'm Kyle. And today my group and I are going to show you how this little guy could help change the world itself. Let's take a look.
Hello everyone, my name is Andres and I'm a brewmaster from Indiana. Beer is an ancient human ritual that started 7,000 years ago in Mesopotamia. Since then, beer culture has spread worldwide. Beer is the #1 alcoholic beverage consumed worldwide. Also, it's the third drink most popular all over the world, just after water and tea. The country leading beer production are the US, China, Russia, and Brazil. In 2015, 193 billion liters of beer were produced. This will be the equivalent of 80 pyramids of Giza in Egypt, or enough to fill 7,500 times the Lincoln Memorial Pools. In the US, 4,000 breweries registered production in that year. The US production in 2015 was 21 billion liters, an equivalent of 10% of the whole production. Beer is a fermented beverage made with 4 main ingredients: water, grains, hops, and yeast. The grains, generally barley or wheat, are malted and then soaked in hot water so they can release the sugar. Then the hop is added to give flavor and to enhance the product conservation. For the fermentation, yeast is added. During this process, sugars are turned into alcohol and CO2. Then other processes take place as maduration, carbonation, filtering, and bottling. Like any other productive process, beer production process also produces some waste. Both consumers and producers are looking forward for a sustainable way of getting beer with the less environmental impact. As I quote, in the fermentation process we add yeast. This yeast will turn into a waste of our process. For every 1 liter of beer we produce, 2 grams of spent yeast will be also produced. This spent yeast will end into a landfill or into animal feed. In the US in 2015, approximately 42,000 tons of spent yeast was produced. That's the same weight of 3 times the Brooklyn Bridge. Can you imagine if we can recover this 3 times Brooklyn Bridge into a more useful process?
Hi, my name is Krista. I'm a scientist here at Purdue University. Today I want to share with you ways we can recover value from spent yeast. This is a diagram of a yeast cell. Inside the cell contains proteins, nucleotides, and other very valuable components. So to recover this value, scientists break down the cell, remove the cell wall, and this resulting product is called yeast extract. It has several uses, such as used as a flavor enhancer and also in food supplements. However, the cell walls, they're usually just discarded as waste. We believe they hold a lot of potential value too. For instance, yeast cells are composed of up to 60% beta-glucan, which is a polysaccharide that has been studied in the past for its immune-boosting properties, but it also has water retention properties. So how do we isolate this precious material from yeast? Well, there are a lot of methods that scientists currently use, but each process has its own pros and cons. To compare these processes, a decision matrix was made based on the following criteria: process efficiency, cost, environmental impact, process complexity, and the value of a final product. The processes we compared were autolysis, acid hydrolysis, enzyme hydrolysis, sonication, and plasmolysis. In the end, sonication was the winner. During sonication, sound energy is applied to agitate the particles. It's an inexpensive and very quick method For instance, one study by Mclaughlin group found that in under 6 minutes, over 90% of the cells were broken. But while sonication on its own is efficient, we can increase the end value of our product using more chemical processes. Our method takes sonication first and then enzyme hydrolysis. After sonication, the product is treated with an organic solvent to remove any lipids. Next, an enzyme is used to remove any remaining protein. This unique combination of processes results in 94% of beta-glucan recovered. This product can then be used in the farming industry in an amazing and surprising way.
Hey guys, I'm Kehui. I'm so glad to be invited here to talk about some soil problems and resolutions. Recently, we are so worried about the soil problems because our soil is degrading. Look at this desert map. The light yellow represents the desert areas. It indicates that the desert areas are gradually substituting our agricultural lands. I'm not sure if you know that extreme weather and unreasonable agricultural activities threaten our soil. The excess tillage may destroy the soil structure and make the soil particles fragile. So the soil may become more easier to be taken away by wind and rain. And with the soil erosion, the nutrients in the soil will decrease dramatically. And another problem is the soil may be too wet or too dry for our crops. So we need to consider the efficient soil management to solve these problems, to improve the water holding capacity and the drainage. So let us introduce one efficient soil management. It's called the soil conditioner. Here's the picture of the soil with and without the conditioner. You can see the right one is the picture of the soil with conditioner. Then the soil particles become wetter and finer. And let me show you the second schematic of the work process of the soil conditioner. The soil conditioner is a product added to the soil to improve the physical properties, including water holding capacity and soil structure. And it will add the nutrients to the soil directly. So now we can mix that conditioner with soil before planting, or place them on the top of the soil after planting directly. So we are always looking for the new, cheap, efficient and environmental friendly soil conditioner. Now the scientists introduced before, the cell wall of the extract contains the 30 to 60% of beta-glucans and sugar polymers. As we know that beta-glucans and other substances can be the stronger potential soil conditioner in the farming. So I'm so excited to see that this kind of new soil conditioner to be widely used in the future.
Wow, how amazing. Seemingly simple yeast can be used for so much. Now that we've seen where our product's been, let's see where it's going. Mineral-based soil conditioners like these can sell for about $26 for a 30-pound bag. Currently, there are no yeast-based soil conditioners available at stores near you. So at this time, we don't have a prospective price for our product. However, our highly skilled research team is undergoing a meticulously detailed market analysis, and we believe that through the use of economies of scope, we'll be able to offer a competitive and affordable product. Domestically, we're planning to appeal to vegan breweries that don't wish to divert their wastes to any livestock operation. Also, the FDA may input more regulations into the practice in the future. We also recognize that larger breweries may be better able to handle this diversion of their waste simply because of their increased infrastructure. Internationally, we're seeking a niche market of areas with poor soil conditioning and an appreciable amount of brewery production. Some countries, alcohol is either banned or there is no domestic alcohol production to be found. So our reach in those areas would be limited. We thank you for listening to this presentation, and we hope that you got something out of it. So, where was I?